Although science has advanced significantly, we still know relatively little about the universe beyond our planet. The grandeur of the night sky has always fascinated scientists, but there have never been enough resources to fully explore it. One of them is the supernova puzzle. Some stars burst into a dazzling last stand known as a supernova when their fuel supply runs out or they suddenly get a surge of new material. The most frequent kind of supernova appears to be 200 times less strong than this new object. A lot of what we know about the cosmos is being disrupted by the cataclysmic explosion of this super-red behemoth that scientists have managed to photograph. What is unique about this supernova and how did it occur? What impact will that have on the cosmos? And most importantly, how will this affect you? For centuries, humans have been fascinated by stars and what they represent. Stars have influenced religious practices and have been used for celestial navigation and marking of calendars. Advancements in astronomy have helped uncover many mysteries about stars, with the list growing daily. Although many stars from the Earth are visible to the naked eye, they are farther than we can imagine. Their huge distance has deceived us into thinking that they are fixed points of light. The observable universe is filled with over 200 billion stars. However, only about 4,000 of these stars are visible to the naked eye and are all found within the Milky Way galaxy. Stars are usually formed when there is gravitational instability within a molecular cloud and are caused by regions of higher density called molecular clouds. These regions are filled mainly with hydrogen, about 23 to 28% helium, and a few percent heavier elements. Oftentimes, stars form in groups of dozens to hundreds of thousands of stars. All the stars in the observable universe spend most of their existence as main sequence stars and are fueled mainly by the nuclear fusion of hydrogen into helium. Supermassive stars can undergo core collapse, a phenomenon where nuclear fusion cannot sustain the core against its own gravity. Once the star passes this threshold, it explodes. The ancient star charts failed to tell us that stars explode when dying out. Thanks to advancements in technology and science, we now know that stars get to a point they die, and when this happens, it leads to an explosion. The powerful and luminous explosion of a star is called a supernova. Supernovas often occur during the last evolutionary stages of a massive star. In this process, the original object, the progenitor, collapses into a neutron star or black hole, or is totally destroyed to form a diffuse nebula. At the peak of its brightness, a supernova can be compared to the light of an entire galaxy and last several weeks or months before fading away. It is that luminous. The chances of observing a supernova with the naked eye are once in a lifetime. This is because the supernova's appearance is brief compared to a star's entire history. The last known supernova directly observed in the Milky Way was Kepler's supernova in 1604. This 17th century supernova came after the appearance of Tycho's supernova in 1572. The two supernovas were visible to the naked eye. Observations of supernovas have been made easier with the advent of modern astronomical telescopes. Furthermore, scientists have gone on to develop techniques for reconstructing supernova events that have no written record of being discovered. This has helped deepen our study of the explosions that occur in outer space. Nevertheless, supernovas will remain a rare astronomical event because only a small fraction of the 100 billion stars in a galaxy can become a supernova. So far, the observed supernovas often come from stars with high mass or rare binary stars. Core collapse is the cause of almost all supernovas. The collapse usually leads to a violent eruption of the star's outer layers, birthing a supernova. However, there are cases where the released gravitational potential energy is insufficient, and this will cause the star to collapse into a black hole or neutron star with little radiated energy. Since we now know how important a core collapse is, the next question is to know what causes this collapse in the first place. Core collapse is usually caused by different phenomena, such as exceeding the Chandrasekhar limit, electron capture, pair instability, and photodisintegration. If a gigantic star develops an iron core that is larger than the Chandrasekhar mass limit, it will be unable to support itself by electron degeneracy pressure. This will make it collapse into a neutron star or black hole. Similarly, electron capture by magnesium will destroy support and cause gravitational collapse and an explosive oxygen fusion. For a large and hot stellar core, generating high-energy gamma rays can activate the photodisintegration process, leading to a total collapse of the core. When scientists studied the electromagnetic radiation released from supernovas, they found out it has a minor side effect, especially for supernovas caused by the core collapse. The emitted electromagnetic radiation is just a small portion of the total energy released during the event. Although the energy output varies for different types of supernovas, a supernova can cause the expulsion of several solar masses of material at velocities up to several % of the speed of light. Supernovas often produce cosmic rays, and their shock waves can trigger the formation of new stars. However, what has been a major concern is how they are responsible for some of the most energetic and powerful explosions in the universe. Astronomers recently made a shocking discovery when they uncovered the largest explosion ever in the universe. This one is nothing like we have seen before. The explosion's brightness is 2 trillion times that of the Sun. Unlike massive explosions that last only a few minutes, the newly discovered explosion's light has been on for the past 3 years. Amazing, isn't it? The explosion, which was produced because a star ran out of fuel, is 10 times brighter than any known supernova. That's not all. This explosion has been found to be 3 times brighter than the brightest tidal disruption event, where a star falls into an immense black hole. Scientists have wasted no time in giving this latest explosion a name, and it has been dubbed AT2021 LWX. What started as a usual flicker of light in the sky at night has turned out to be the largest cosmic explosion in our world. Astronomers are still shocked about the explosion's duration, and it now holds the title of the most energetic explosion in the universe. It's nothing like they have seen before in their study of supernovas. AT2021 LWX occurred 8 billion light-years away when the universe was about 6 billion years old. That's a very long time. According to Dr. Philip Wiseman, a research fellow at the University of Southampton, the discovery happened by chance. The research team led by Dr. Wiseman had been searching for a type of supernova when their search algorithm flagged down the explosion. We have estimated its fireball to be 100 times the size of the solar system, with a brightness about 2 trillion times the Sun, says Wiseman. In 3 years, this event has released about 100 times as much energy as the Sun will be in its 10 billion lifetimes. The explosion had first been detected in 2020 by the Zwicky Transient Facility in California. The discovery surprised the scientific community and motivated many researchers to investigate the massive explosion further. Wiseman's team's initial shock was because the explosion was outside the plausible range for an exploding star. They initially thought it could be other common scenarios that cause bright flickers in the night sky. This is because these events involve a star straying too close to a black hole and becoming destroyed, with a part being swallowed and the rest being stretched out in a swirling disk. When simulations were carried out, it suggested such a possibility could only be due to a star up to 15 times the mass of the Sun. Thus, Wiseman and the team discovered that they were dealing with a huge star. Further observations were carried out by the Asteroid Terrestrial Impact Last Alert System, ATLAS, and Neil Gehrels' SWIFT telescope. Their work was supported by the investigations of the New Technology Telescope and Gran Telescopio Canarias in La Palma, Spain. As part of their investigations, astronomers analyzed the spectrum of light that was being picked by the telescopes. The light was divided into different wavelengths for easier investigation, so astronomers could measure the absorption and emission features. A major part of their investigation was seeking answers on the cause of the explosion. Astronomers have hypothesized that the explosion was caused by a very large cloud of gas, mainly hydrogen, or dust that went off course from its orbit around the black hole and was sent flying in. This belief is not unfounded when you consider the fact that most extreme and large outbursts are due to jets emitted by supermassive black holes. These black holes often eject particles all the way into the intergalactic space. Most of the outbursts occur in a star when there is smashing into the surrounding gas and plasma, and this creates cavities that can last for millions of light years. Yet, scientists are still unable to confirm what knocked it off from its orbit and down the cosmic sinkhole. There are still a lot of unanswered questions about this most powerful and largest explosion. Scientists still want to probe further, but have been restricted by a lack of equipment to perform such a level of investigation. However, this won't be for long because new facilities are on their way, and one of them is the Vera C. Rubin Observatory. which was formerly known as Large Synoptic Survey Telescope, LSST. The observatory gets its name from American astronomer Vera Rubin, who pioneered discoveries about galaxy rotation rates. Vera Rubin Observatory will allow deeper observations of this largest explosion. More importantly, it will help us discover more explosion events like this and uncover deeper facts about them. According to Dr. Wiseman, using highly sophisticated facilities like the Vera C. Rubin Observatory will help us confirm if these events are so energetic that they are key processes to how the centers of galaxies change over time. The Vera C. Rubin Observatory is yet to come online and will not be until October 2024 before full survey operations begin. The idea for the Astronomical Observatory was conceived in 2001, and its main task will be to carry out a synoptic astronomical survey dubbed the Legacy Survey of Space and Time, LSST. The observatory is situated on a 682-meter-high mountain in the Coquimbo region of northern Chile. Due to the groundbreaking discoveries the observatory is expected to uncover, the project is sponsored by the National Science Foundation, the United States Department of Energy, and private funding raised by the nonprofit organization, the LSST Corporation. Vera Rubin Observatory is a reflecting telescope equipped with a novel 3-mirror design and CCD imaging camera that will be used to detect transient astronomical events such as novae, supernovae, and gamma-ray bursts. The discovery of AT 2021 LWX means that the gamma-ray burst, GRB 221009A, is no more the most powerful explosion in the observable universe. A gamma-ray burst is another transient astronomical event occurring in the universe. Sometime in 2022, astronomers discovered GRB 221009A, which at the time was the brightest explosion ever seen. However, the event lasted only a few hours. The Neil Gehrels Swift Observatory and Fermi Gamma Ray Space Telescope jointly discovered the gamma-ray burst on the 9th of October 2022. This once-in-10,000-year event is one of the closest gamma-ray bursts discovered by scientists. It had remained visible for 10 hours after its detection, and some lucky amateur astronomers were able to spot it before the light died out in deep space. The gamma-ray burst joins the list of the most energetic and luminous explosions discovered by astronomers. When the burst occurred, it oversaturated the Fermi Gamma Ray Space Telescope, which captured photons with energies exceeding 100 GeV. The high-intensity emissions from the burst span 15 orders of magnitude of the electromagnetic spectrum from radio to gamma rays. These results allowed scientists to study it and other events in greater detail. We can expect scientists to discover new facts about the effects of the burst because the radio signals will last for years to come. The gamma-ray burst is from a constellation called Sagitta and occurred about 1.9 billion years ago. From astronomers' findings, the burst is at a distance of 2.4 billion light-years away from the Earth. Reports from the Large High-Altitude Air Shower Observatory in China show that the burst produced about 5,000 high-energy photons. At the time, this was an unusual discovery because scientists had only detected hundreds of such photons in the history of studying gamma-ray bursts. By comparing data from different observatories, researchers concluded that the astronomical event was 50 to 70 times brighter than GRB 830801. The latter event was the previous record holder of the brightest burst in the universe. It occurred on the 1st of August 1983 and was the first detected gamma-ray outburst in the upper atmosphere. There have been speculations about the discovered gamma burst of October 2022. Some scientists believe that it was caused by a fading massive star undergoing a supernova, while some say that it is due to the birth of a black hole. The high-energy photons from the burst have made some astronomers hypothesize that the photons could come from new physics involving dark matter and axion. Further studies on the gamma burst have been carried out by the Neutron Star Interior Composition Explorer, the Monitor of All-Sky X-ray Image, the Imaging X-ray Polarimetry Explorer, and the International Gamma Ray Astrophysics Laboratory. Scientists at these observatories hope to use the event to study how matter interacts at relativistic speeds. In 2020, a powerful explosion rocked the observable universe, and when scientists investigated it further, it was found to have occurred in the Ophiuchus galaxy cluster. This cluster is located about 390 million light-years from the Earth. Astronomers were drawn to this astronomical event immediately because galaxy clusters are the largest structures in the universe and are held together by gravity containing thousands of individual galaxies, dark matter, and hot gas. The Ophiuchus supercluster was discovered by Kenichi Wakamatsu of Gifu University and Matthew Malkin in 1981. The discovery had been made during a hidden globular cluster survey. From the observatories of NASA and the European Space Agency, scientists pondered on what could have caused this massive explosion in the Ophiuchus and examined data to answer this question. Hot gas can exist inside galaxy clusters like the Ophiuchus, and they give off much of its light as X-rays. Scientists looked at the cluster and found a large galaxy in the center of the cluster, which contains an extremely massive black hole. Further observations revealed that the explosion was due to jets of particles that had been blasted away from the black hole, creating a gigantic hole in the hot gas. The observations showed that the densest and coolest gas seen in X-rays is located about 6,500 light-years to the north of the central galaxy. Until the discovery of AT 2021 LWX, the Ophiuchus galaxy cluster explosion was the largest explosion recorded in the universe. So far, the large explosions caused by supernovas have occurred billions of light-years away. But have you wondered if a supernova was to occur very close to the Earth? What do you think will happen? The honest answer is that it will be a disaster. For centuries, we have been protected from the deadly gamma radiation from supernovas because they occur millions of light-years away. However, if the gamma radiation from the supernova were to occur a few light-years away and reach the Earth in large quantities, it would cause the fragile ozone layer to break down. If the ozone layer is damaged, we become exposed to harmful cosmic radiation that can cause cancer, genetic mutations, and radiation-induced sicknesses. It would also affect global temperatures, increasing them by 3 degrees C to 4 degrees C, and this would cause oceans to rise and adverse climate change. This effect can last for centuries to come, as food production will be affected drastically. We can only hope that this doesn't become a reality as we continue to support scientists in their research about supernovas and the large explosions that they cause.